Hello, everyone, and thank you for coming back on our slightly postponed meetup. I am Ben Pick with the OWASP Nova chapter. I have right here Grayson he's a security researcher at R2C, and I don't actually have any housekeeping items, so just listen to our meetup, our Twitter accounts for our next month's meetup and the month afterwards. And take it away, Grayson.
Okay, thanks, Ben. Thanks everybody for having me. A special thanks because there was a little bit of a scheduling hiccup that we had a couple weeks ago. So I'm thrilled to have a second chance today to be able to present. Before I get started, I think I'm in the YouTube chat, or at least I'm trying to watch it. And so if anybody has any questions, then feel free to post them there. I know Ben and I were talking before that he said he'll also be monitoring it. And if there are any questions that come out that I miss or I'm not seeing, then he'll pop in and ask me some stuff. Anyway, the point is feel free to interrupt if you have questions throughout the whole presentation. We'll go ahead and get started. My presentation today is about scaling your security by embracing secure defaults and eliminating bug classes. So we'll go ahead and get started. A little bit about me. My name is Grayson Hardaway. I'm a senior security engineer at R2C. This is me and my lovely wife over here. And in a past life, I used to work for the US Department of Defense, doing things all up and down the security chain. So since this is OWASP Nova, I've been in that world before. It's fun. I miss it some days. Nowadays, I work at R2C, which is a San Francisco-based startup. We do static analysis. We're on a mission to profoundly improve software security and reliability. And so this is a little screenshot, or a picture, actually, it's a real picture, post or pre-COVID days of the team at R2C, and I want to give them all a special shout out because nothing you see here would be possible without them. It's a great team to work with, incredibly smart, incredibly humble, and I really enjoy getting to spend my days with them. So a quick outline of the talk. We're going to start out with why bug finding isn't the answer. We're going to talk about some shifts that have happened in the development world and some shifts that I think are happening in the security world. The second big topic is going to be how to eradicate vulnerability classes. And so really what this is going to be is a proposal from me about how to go about eradicating vulnerability classes from code. So it's a proposed strategy that I'm going to give. And then the third section of the talk is going to be about what does this look like in practice. So some tools and techniques to make it real. And then I'm going to talk about how we do it at R2C. So getting started, why bug finding isn't the answer. So in the past 10 years, software development has changed. At least it definitely has since I graduated from undergrad almost a decade ago. Security teams have to sort of shift alongside them. And the reason for this is that, security teams rarely have the ability to hard block engineering. Usually it's the other way around. Engineering is going fast, they've got to deliver, they're the ones providing business value. And so security teams, it's really hard for us to say no for all the reasons that exist in an organization. Because development has shifted to be continuous, security also has to be continuous. No longer can we be content with taking snapshots of our security posture every quarter. We've got to do it all the time in an automated fashion. In the past, security teams were focused on breaking. Now we've got to focus on building. And then we've also got to focus on our role as partnerships closely, or as partnering closely with development teams, rather than as sort of in parallel to, or sometimes in opposition to. So we need to revisit our prior assumptions. Just a kind of an example of some of the shifts that we've seen. So in the past, for development, we used to do waterfall development, gather all the requirements, design everything up front, and then just execute on these massive projects. Now we're much more agile. We iterate. We do things in much shorter time frames. In the past, there used to be stovepiped dev and ops roles. Now there are DevOps roles. In the past, everything used to be on-prem, and you used to have to design everything in all your network requirements yourself. Now you just use the cloud, and most of that's taken care of for you. And so in the security world, I propose that this shift is happening, where in the past we used to focus on finding vulnerabilities, and now we're shifting to focusing on secure defaults and invariants. And so what is an invariant? It's a fancy word, but it just means that it's a property that must always or never be true. And so the key insight about a security invariant in particular is that no context is needed to make a decision, which means there's no operational time needed for the security team. So what does all this mean? If let's say that you set the invariant on your projects or in your organization that you'll never use raw SQL queries, you always use an ORM or some other safe SQL library, that's your invariant. Never use raw SQL, always use some other thing. That means if you ever see raw SQL in your code, there's no longer any context needed to make a decision. There's no operational time needed to figure out, is this an actual vulnerability, whatever. We've just said, no, we don't do things this way here. We are doing things this way, which is much safer. So let's kind of walk through a quick example of what this might look like in theory/practice. So quick quiz, does this app have XSS? Well, in order to answer this question, we actually have to answer a lot of other sub-questions. What is the user control? Like, what data do they have available to them? What is the structure of that data? Is it JSON? Is it a form, like an HTML form? Is it HTTP headers, because that's something they control? Then, like, between the app and the database, like, is that input sanitized or filtered in some way? Then in the database, how is it stored? What are the types that it's stored as? Is it an integer? Is it a string? When it comes out of the database, is it sanitized? Is it encoded in some way? And then when it gets rendered on the page, what context is it being rendered in? Is it in an HTML, or is it in HTML, or is it an HTML attribute because the safe characters are different in an attribute than in regular HTML, or is it in JavaScript because the safe characters are different there too? So you have to be able to answer all these questions in order to answer the question, does this app have XSS, which is a lot. So alternatively, what we can do is we just set this invariant on our app. We say our front end is developed in React, and then we ban dangerously set inner HTML. And so React, in particular, is a front-end framework that has was developed with an eye towards mitigating XSS as best as it could. And so the way that you dodge these safety mechanisms that are built into the framework is with this special, very difficult to type, you definitely know what you're getting into, parameter called dangerously set inner HTML, which allows you to go around the safety mechanisms. So if you set your invariant to be, we're using React, we're banning dangerously set inner HTML. Now the only question you need to answer is dangerously set inner HTML anywhere in my code? And if the answer is no, then you can be reasonably sure that you don't have cross-site scripting in your application. If the answer is yes, then you might. You have to go answer that. And so as you can see, like, key insight, no context needed to make a decision. If you don't have dangerously set inner HTML, it's unlikely that you have cross-site scripting in this app. Same thing with RCE. What does the user, or what does the data look like? What's the structure of the data? Is it sanitized in any way? How is it stored? Is it sanitized when it comes back out? And then, like, what are all the ways that RCE can happen? Is it, it can happen when stuff gets deserialized. It's very common. Shell commands, like shelling out to other things. Meta programming, where you, like, format a string that you then execute as code, something like that. You can set an invariant on your app that says ban all these, like, dangerous syncs in your code. And now you no longer have to answer all these other questions. The only question you have to answer is any of these functions present in my code? And if it is, then you might. And if you don't, then you don't have to worry about it. So this is a very hand-wavy graph about the effort required versus the task at hand. And so on the left, on the bottom, is detecting the use or the not use of an insecure or secure library. Harder than that is finding a potential bug. Harder than that is confirming it's a real bug. And harder than that is writing a proof of concept exploit. So you can see at the bottom, it's easy to detect functions. It's harder to prove that an exploit exists in the code. To sort of drive it home that invariants are easy and useful, let's imagine that this pie chart is like the amount of time that you spend on things as a security team. You might do some threat modeling. You might, like, run some security tools and read the reports. You might, like, triage a bug bounty, you might be in the code yourself fixing XSS or SQL injection. So let's say that you try to tackle cross-site scripting using defaults and invariants. You set your invariants, and you are able to do this. Well, you've just eliminated this whole chunk of the pie chart from the total amount of time that you spend on things, which means you get a lot of time back. So this has compounding returns, because what could happen next is you could say, like, okay, well, this worked. Let's focus now on SQL injection. So you eliminate that one, and now you've got time to focus on interesting stuff or the really exotic bugs that you may be tracking, instead of the really common ones like, oh, is this another SQL injection with that somebody just wrote a raw SQL query for or something. So the core takeaway that I'm getting at here is that detecting invariants is much easier than finding bugs. It's faster, it saves you time, and keeps you from having to answer a whole lot of questions. And because this is 2021, here's the obligatory meme. Broke is finding every vulnerability. Woke is preventing classes of vulnerabilities with invariants. And so all I've really done is kind of like talk about things at high level. And it's basically just been an opinion so far. So is anybody else doing this? Is there any proof that this works? This is a screenshot from a presentation by Netflix in 2018. And the arrows kind of demonstrate that they're de-emphasizing these manual modes of doing things, and they're trying to emphasize what's called paved road, which is their definition of, or their term for secure defaults and invariants. And they're focusing more on killing bug classes as well. And so this is also a presentation from Netflix a year later, where you can see that they're trying to focus more and more on secure by defaults and less on the other things. So how about some data? Other people are doing it. Is there any sort of like quantitative evidence about this? Microsoft published this blog, I think in 2018 or 2019, reflecting on some of the stuff that they've done in the past. And one of the really interesting data points that came out from it was that 41% of vulnerabilities were reduced in the transition from XP to Vista just by banning strcpy and its friends, like the other dangerous, low-level functions there, which is pretty huge. Like 41% is non-trivial. I would be thrilled if I didn't have to worry about 41% of my vulnerabilities. Traditionally, the way that we've tried to approach these kinds of problems is through sort of telling developers and software engineers and telling ourselves, like, hey, this is the safe way to do it, this is not the safe way to do it. And so I've used SQL injection a number of times as an example in this presentation. That's kind of one that we've definitely beaten into the ethos of many software shops around the world, which is, don't write raw SQL. Use an ORM as much as possible, or some other library as much as possible. But while that's kind of a success story, it's not enough. This is a quote from that same article. Tools and guidance are demonstrably not preventing this class of vulnerabilities. Memory safety issues have represented almost the same proportion of vulnerabilities assigned a CVE for over a decade. So this is a quote from a book that Google published last year, which is really cool, really good read. It's unreasonable to expect any developer to be an expert in all these subjects or to constantly maintain vigilance when writing or reviewing code. A better approach is to handle security and reliability in common frameworks, languages, and libraries. Ideally, libraries only expose an interface that makes writing code with common classes of security vulnerabilities impossible. So the gist here is that humans are fallible and they forget things and they do things wrong sometimes. And so instead of trying to get them to remember everything, like, let's help them out by making the tools safe by default. Facebook does the same thing. Quote from them, we invest heavily in building frameworks that help engineers prevent and remove entire classes of bugs when writing code. You can see here, this little stack chart over here, that the biggest section that they focus on is secure frameworks. And so you might be thinking that, like, you're not Google or Facebook or Netflix or any of these big guys that have the tools and the time and the resources to throw at stuff. But oh, what a world we live in, because we have options. We have options in the form of open source code. So it's been really cool over the past number of years to see like security awareness being built into frameworks by default. One of the best ones that I've seen is React, as I mentioned before, which was written by Facebook. They published it for anybody to use. So we have options. So while we may not be able to cover everything, like it's becoming more and more accessible to the everyman as time goes on, which is great. Other options include things like DOM Purify, which does context-aware encoding for web pages to prevent cross-site scripting. And another one is like RE2, which is a drop-in replacement for the default Python regular expression module. The default RE module in Python is vulnerable to denial of service under certain circumstances. RE2 has an identical, well, as far as I understand, so I won't say identical, I'll say mostly identical API that is not vulnerable to the denial of service that the regular one is. So yeah, a lot of that is like why, so all of that was like why bug finding is not the answer. It was some persuasion to maybe convince you that secure defaults might be helpful. So if you assume that, then how do we do that? So this is a sort of high-level strategy that I'm proposing for how to eradicate vulnerability in classes. So the first step is that you have to pick one. You have to pick a vulnerability class to target. The second step is to identify your safe patterns and make it default. The third is to train developers to use the safe pattern. And then the fourth step is to use tools to enforce the safe pattern. So when you have to pick a vulnerability class, I typically recommend that you stack rank the vulnerabilities that you want to target. So you have to prioritize them. You can't work on everything all at the same time. You can't work on everything all the time. So you have to like work on things in some order. And so prioritization can help with that. And so some criteria you can use to prioritize your vulnerability classes could be the ones that are most common in your organization or the most prevalent, the ones that have the highest impact to you or the greatest risk, the one that's the easiest to do. So maybe you're just getting started or you're new in a security field or don't have a whole lot of resources to spend on this, and this would just be like a side project. Start on something that's easy to do. Or organizational priorities. Maybe your CISO is like really worried about one particular vulnerability class. You could use that as a metric for how to prioritize things. Otherwise, like there's always some weighted function of all of these things that you can take into account. The point is to prioritize them. So if you are fortunate to have a strong vulnerability management program, then that means you have historical data to draw on for your prioritization. So you would know the bugs that you've had historically. You have a root cause for where they are. You might have reports or bug bounty submissions or pen testing reports or anything like that. Everything will be organized by risk, by impact, etc. And so if you have that, you can slice and dice your vulnerabilities in your vulnerability management database in order to help you prioritize. But in reality, most people don't, including myself. I don't have one. And so a shortcut could be to use some scrappy sources in order to help find answers to things like which vulnerability is most prevalent. You could look through your issues for things that are tagged security or that have a certain vulnerability string like XSS or SQLi in it. Or you can search through the commit history of your projects, which I've totally done. In order to find vulnerabilities that we found or that we've had in the past. If you have static analysis tools or dynamic analysis tools running, you can check those reports, pen testing, bug bounty submissions if you have them, etc. And you can just ask people too. Like you can ask your engineers, like, hey, what security issues are you worried about? You can ask your security people what they're worried about, ops people what they're worried about. They might have a pretty good impression of something that's concerning them. So yeah, if you haven't done this yet, if you haven't created like a vulnerability tracking, if you do this using these scrappy sources, like put it in a spreadsheet or something because it'll save you time later. Once you have data, you can slice and dice. You can group by whatever you want, impact, prevalence, whatever. And then in an ideal world, you can choose a vulnerability class to prioritize. You can choose one that's widespread amongst all your teams or projects. You can, the class that you select will be high risk. It'll be feasible to get devs to fix. It'll align with company priorities, and it'll be always broken the same way, which means it's easy to fix it the same way every time. But we don't live in an ideal world, and so if there's anything that you take away from all of this, is just pick one. Just pick a vulnerability class and run with it. Try to eliminate it. So SQL injection, cross-site scripting, command injection, code injection, JWT usage, authorization, authentication, whatever it is, like secure logging, whatever. Pick something and run with it. So after you've selected a vulnerability class, the next step is to select a safe pattern and make it the default. So there's two parts to this. So you gotta find the safe pattern, and then you have to make it default. Some great resources to leverage for finding safe patterns for certain vulnerability issues is the OWASP stuff. So the OWASP cheat sheet project is amazing, has great resources, and often even has code examples of like exactly what is bad and what is good, which is fantastic. Another resource is the Application Security Verification Standard, ASVS, that OWASP maintains, which is also great. And it has a lot of really good ideas for like, oh, I need to check for this in my code, I need to check for this in my code. And they're grouped into buckets by sort of rough vulnerability classes, which makes it really helpful. So the second part of this is once you've identified the safe pattern, you gotta make it default. That's the second part. So one way you can do this is like update all of your internal coding documentation, guidelines, whatever. So if you have coding standard docs, like make sure it gets updated there. READMEs, developer documentation, FAQs, training slides, onboarding, whatever. Whenever you highlight these patterns, make sure you explain like why they exist and how to use them. Like why this particular pattern is bad. Here's the safe alternative. This is why. If you have a developer productivity team or a developer advocate, then work with them to try to ensure that devs are aware that the secure alternatives are just as good as or even better than the old way. One hack you might try is to create like project starter templates for tech stacks that you have in your organization that use the safe alternatives by default. So, as an example, like if you don't want people using the default regular expression library in Python, you can create a project template that uses RE2 by default, already has the dependency manager ready to go so that it can just install RE2, and then you can have people fork that as a way to start the projects. The third step is to train developers to use the safe pattern. So developers need to understand. Developers love learning things, and the best thing that we can do to help them is to help them understand why something is the way it is. And so in any messages that we end up like conveying to them about why particular patterns are bad versus good ones, we need to explain what and why something is insecure. And that needs to be extremely clear. We need to convey impact in terms that developers care about. So developers don't care about like CVSS scores. They don't really care about SWEs either. And so we have to convey what the issue is in terms of like risk to the business or damaging user trust or reliability or uptime or something that they care about. And then anytime that we sort of like confront a developer with a bad pattern, we must propose a fix, and it should be concise and clear. I heard a brilliant example of this the other day from a colleague at a different company, where one of his developers had accidentally checked in a API secret into the repository. So you know how it is, you're just like type in a million git commands a minute, you accidentally check in a file that you didn't need to, and it ended up in the repository. And so what he did was he created in his static analysis framework a new rule to check for that specific kind of secret. And then when that developer checked in a new commit the next time, a message popped up that said, hey, this pattern or this secret was detected. Your next steps are remove it from your Git and rotate the secret. And that developer did exactly that as soon as they saw the message, which is like super cool that that happened. Here's a template if you need one. Like this is a template from a gentleman named Morgan Roman who was working at Coinbase at the time and may still be. So I'll just read it here. If you use the bad way, this bad thing will happen. Instead, use the good way since it stops the bad thing. Do not do this. I provide an example. Do this instead, an example of the good way. Other options for engaging developers for training is obviously developer onboarding, educational brown bags. So you can just have like a session where you invite people to come learn about some things that you've been learning about as you learn about safe patterns. Internal CTFs, if you have security champions, have them go evangelize in various places. And then whenever in-person interactions begin, have some candy on your desk so they can come by and you can tell them about all the cool things you're learning. So as I mentioned earlier, though, training is great, but it's not enough in order to prevent this. And so the fourth step, and arguably the most necessary one, is to use tools to enforce the safe pattern. The way I propose doing this is with lightweight static analysis. And the key there is lightweight. You don't need anything heavyweight in order to do this to ensure that the safe patterns are used. So a couple of options for this are, you can use grep. Grep is great if you're trying to detect something in your code, like dangerously set inner HTML. It's perfect for that, just because it's such an easy identifiable string. Grep is really easy to use, so there's some pros to this. It's interactive, it's fast. But the downside with grep is that if you've ever used it to try to match code, you might catch comments or documentations or other things. Grep is not aware of code, it's only aware of lines, which is a downside. So another option is that you can use a code-aware linter if you want. Code-aware linters are going to give you much more precision. It understands white space and comments, so you won't get mismatches on those kinds of things. The downside of the code-aware linters is that the ones that are available to us to interact with there's a high barrier to entry. And so this is especially true if you've got like a lot of different languages or frameworks in your organization. So if you have to learn how to parse the AST for Python and Go and Java and JavaScript, like it's going to take a while in order to like get rolling on this thing. And so each one has pros and cons, and so you've got to weigh it for whichever scenario suits you the best. Cool. So that was kind of like my high-level proposal of a strategy for how to eradicate vulnerability classes. As a reminder, it's number one is you select one. Number two is you select a safe pattern, make it the default. Number three is you train developers to use the safe pattern, and then the fourth is you use tools to enforce it. I'm going to talk about some tools and techniques to make it real in your organization, and then I'm going to end with what we do at R2C in order to implement this strategy. So the two things that I'm going to focus on for this in particular are under this fourth bullet here, use tools to enforce the safe pattern, which is how to set up continuous code scanning and checking for escape hatches and secure frameworks for detecting violations of invariants. So some continuous scanning best practices, the pull request or the merge request or whatever the sort of analog is in your system is a great unit of work to scan. It allows blocking for violations of invariants before things get into a mainline version of the code, whether that be production or whatever you call it. If you're in the CI/CD pipeline, then you need to be fast. The reasons for this is that, well, I mean, nobody likes slow stuff, but even more important than that is that, like, the sooner you can provide feedback, the context is fresh to whoever's working on it. So the chances are higher that they'll be able to fix it without much extra work. if you have the capability, something that I like and that we do is 2 scanning workflows. So you have one for auditing and you have one for blocking. So the blocking workflow is obvious. It's like, these are the secure invariant violations that we don't want in our code. But the auditing workflow is interesting because it kind of allows us to do a couple of things. One is, if we're not confident or we're not comfortable hard blocking our devs, then this allows us to, this is an alternative for that. And so it allows us to monitor things such as, hey, we found a raw SQL query here, like we need to go look at it. Hey, this happens to be vulnerable, and you can go talk to the devs about it. The other thing that auditing gives you is it allows you to look for things that are not necessarily security vulnerabilities in and of themselves. And what I mean by that is one way in which I've heard of people using this audit workflow is anytime a new route gets added to their application backend, they'll get an audit notification that says, like, hey, a new route was added, like, go take a look at it to make sure it's not doing anything. And the reason for that is because if you add a new route to your application, it expands your attack surface, and so they just want to be able to have eyes on it, make sure that there's nothing egregious inside of it, which is pretty cool. I really like that idea. When you're in CI/CD pipelines, don't come in last. It's a good rule of thumb for how fast you need to be. So it's the old analog of, like, you don't need to be faster than the bear, you just need to be faster than the slowest guy. The same is true here. Don't be last, because if you're last, people will complain. The earlier you can report violations, the better. So the earliest possible place you can do this is in the editor or in the IDE or in whatever environment your developers work in. The next step is probably at least using Git as an example at commit time, and then after that, of course, you have any pushes or pull requests that get made into the mainline branches. So the earlier in the process that you can provide the feedback, the better, and the more likely that things will get fixed. When you display results to developers, try to make sure that they're within the same systems that they already use. So if you have a system, make sure it can leave comments on code reviews or something like that. Make sure that the messages that get displayed to the developers are clear and actionable, and then have references for more information if they need it. And then developers need an option of moving on from this result, especially if it's not useful. And so this is the screenshot, if I can take a chance to explain, which I realize I didn't do at the beginning and I should have, is a screenshot from Google's paper on Tricorder. Tricorder is their big program analysis ecosystem. And so this is a code review comment that got made on a line of code. It explains what the issue is. And then it provides a developer the option to say, to actually argue the result. It says, hey, this actually is invalid with this not useful button. And so developers need to have that freedom because we don't know the context of everything. And so they need to be able to not necessarily opt out, but at least engage with us to make sure that this is that opting out is a safe thing to do. If you're interested in more continuous scanning, best practices, here's a ton of other presentations that you can go check out. So they're all here in the slides that you can peruse at your leisure. So the thing that we want to use the continuous integration for is detecting the escape hatches, obviously. So these are the kinds of things that we want to look for. Dangerous set HTML is an example that I used earlier. Exec is an example that I used earlier. Raw SQL is an example that I used earlier. You might have something organization specific too. So if you have a specific way of doing authentication or authorization at your organization, you can try to make sure that gets scanned for as well. If you can, autofixes are great because it literally reduces the amount of thinking a developer has to do in order to fix something to 0. And so it makes their job easier, and it makes our job much easier because we know things are getting fixed. How do we check for these things? This is the same slide that you saw earlier. We've got a couple of options. Each one has pros and cons. Grab a code aware linters. And you can implement both of those into CI/CD pipelines. Each one usually has its own, hurdles in order to integrate. So last thing I want to do is talk about how we do it at R2C, how we do security variants at R2C. So we use Semdrip, which to anybody who's familiar with us probably isn't a surprise. Semdrip is a tool that we inherited and we maintain that sort of tries to strike a balance between grep and typical code-aware linters. So it tries to make code queries, like actual code queries, not line queries, really easy and intuitive to write and fast to write. So this is just a reminder of the process that I'm going to walk through now. So selecting vulnerability class, what we did, we're really young. Our company is 3 years old as of yesterday, I think, which is cool now that I think about it. So the company is 3 years old. We only have 2 primary code bases, and we have limited vulnerability history because we're just not out there in the public that much yet. So the prioritization scheme that we use is that we focus on common problems for the type of application. So rather than like relying on vulnerability history or like or some other metric, we knew the type of applications that we had. We have a web application, and then we have a command line interface. Those are our 2 main code bases. And so we pick vulnerabilities that are common to those. And so for the web application, we pick cross-site scripting, and for the command line interface, we pick code and command injection. Which that didn't happen. And so I'm going to focus specifically on the web application. I'm not going to talk too much about the command line interface. So our web application is the front end is React and the back end is Flask. And so for step 2, selecting the safe pattern and making that the default, I mentioned way back in the beginning of the presentation that in React, the main thing you have to worry about is dangerously set inner HTML. And so we check for that. So we use React, and we have a Semdrip rule that runs on every pull request that checks to see if dangerously set inner HTML is ever set. And if it is, then it blocks the build and politely asks that the developer do something else. Flask is a little bit harder because there are a lot of like gotchas in Flask for XSS. And so we basically conducted this like extensive research campaign where we identified a bunch of different ways that you could skirt around the typical XSS preventions in Flask. And then we came up with this, which I call a policy that explains, like, on the left over here, it's like, this is the thing that's bad. On the right, it's like, this is the alternative. And then in the middle is the Semdrip rule that we wrote in order to detect this thing continuously. And so the gist here is that, like, React was easy. For something that's a little bit harder, it takes a little bit more legwork because you got to go figure out kind of like what are all the ways that this can happen, and then what do we want our developers to do, and then you have to sort of create this bridge or road, which I guess is why Netflix calls it the paved road, in order to make sure that these things happen. We publicize this, so like that Flask security, like XSS security policy is public, and if you're interested in using it, like if you want to use the way that we set this thing up, then you can download it and use it with Semdrip. They're available here as a Semdrip rule pack, XSS, and they're available as cheat sheets too if you just want the information on our website at semdrip.dev/docs/cheat sheets. Step 3 is to train the developers to use the safe pattern. We're small, we move fast, and I'm lazy, which means the primary way in which I sort of educate developers is through the messages that get presented to the developers through the code scanning. And so we have a couple of integration points. We have one that we have a couple of options for integrating into IDEs. So our IDEs get used and messages get displayed there. And then it's also integrated in our continuous integration, our CI/CD pipeline. So they're in both places. It's the same message both times. It tries to reiterate, this is why it's bad. This is what you should do instead. And so this is kind of like a quick overview of how things are set up for us. We use a centrally managed platform for managing our security policies. And so that's this thing down here at the bottom. As I mentioned before, we use Semdrip to do all this. And then we push our security policies out into two places. We push it out into our CI/CD pipeline. We use GitHub Actions for this. And then we also push it out into files that are in the repositories that are checked in as that are checked in and used alongside pre-commit. And so pre-commit's like a tool that will run some stuff every time a commit gets run. And then we also have editor plugins, like I mentioned, but we don't have a way to push policies into the editor configs yet. So those, basically, we just tolerate some staleness there because we know that it's going to get caught in other places. Once we've pushed all this stuff out, we keep track of what gets reported and what gets fixed. And this is kind of like our high-level dashboard. You know, at the time of this screenshot, we can see that 76% of things were fixed, which means the other 24% had not been fixed, which kind of allows us to see how we're doing and seeing if stuff that's getting reported is actually getting actioned upon. One additional thing that I like to do, like I said back in the beginning, or like back in the middle of the presentation, is to keep things quiet sometimes. So if I'm deploying new rules, I will privately deploy new rules into our Semdrip configs, but only have them notify to me or to the security team. And so if we're working on something new that we're not sure of the efficacy of it yet, then this is how we'll do it. So we'll quietly deploy these rules out, monitor them, you know, behind the scenes, and then once we're pretty sure that they're going to be okay to put in front of developers, we'll promote them into a mode that they can see. Okay, so that was a lot. Thanks for sticking with me. Some quick concluded points. Security defaults are the best way to scalably raise your security bar. They're easy to do, easier to do at least than finding every single bug. Killing bug classes makes your AppSec team more leveraged. It gets you time back every time you deploy it. Every time you deploy a rule that's preventing a bad pattern, you get time back because you don't have no longer have to worry about it. Yeah, and then quickly reiterating kind of the strategy, it's like define a safe pattern, educate, roll out, and enforce continuously. That's my talk. That's everything I have. Thank you for having me. And if there are any questions, I would love to field them now. I think you're muted, Ben, or at least you're muted to me.
Sorry about that. Yeah, so the chat window has been pretty quiet throughout the talk. But I did have one question while you were going through. So if I absolutely wanted to use dangerously, you know, dangerously set inner HTML, is there a way to still maintain the rule but have like that one line exception and then every other instance be, you know, be caught?
Yeah, definitely. Definitely. So many linters, at least, will have some sort of suppression mechanism, and it's usually in the form of like a comment syntax. And so I know, well, I was going to say I know, and then I forgot the tool. ESLint, at least I know, has some comment syntaxes where, you know, you can say like ignore the next line or ignore this particular rule on this line, and it will respect that. And so the way that we do this is we keep track of those as well. And so anything that gets sort of suppressed or exempted, we have sort of a separate bucket and in a separate view from everything else. And then every once in a while, we'll go back in and we'll take a look at it and be like, okay, this is actually like a safe exception, or no, this isn't a safe exception, and you shouldn't have done this. Most of the time, actually, I have not been involved in a time where the exemption has been an issue. And so I'm fortunate to work at a place where devs are pretty security conscious, and so they exempt responsibly.
Okay. Yeah, so we can hang around for another minute. I was kind of just stalling to see if anybody in the chat had any additional questions, but right now we just have some, thank you for the talk. But I will flash your contact information up on screen as we just sort of sit around. So it looks like they can just email you if they have any follow-up questions. You can also see that the slides are available at the URL on screen. And yeah, again, thank you so much for coming in. I know that there were some initial issues which we had to cause us to postpone and reschedule, but again, you still came in, you presented this great talk, and I just want to thank you for doing that.
Yeah.
We greatly appreciate all of our guests, and yourself included.
Thank you so much, and thank you for working with me on it. I'm still sorry about it. Thank you.
These things happen, not a problem at all. So yeah, again, it just chat window is just more thank you for the talk. There aren't any questions yet, so
cool. Yeah, we have a community Slack that is pretty active, so if anybody's interested in doing that, I realize it's missing from this slide actually, that could be added. Yeah, there are tons of people there. Well, I say tons. There's 100 or so people there, and very active. So if you have any other questions, you can come hang out with us there.
Sounds great. So I'm going to close the broadcast in just a couple of seconds. But again, I want to thank you for coming in one more time. And I want to thank everybody for joining us. And I hope we'll see you all again, if not next month and the month after that, for our upcoming talks. So take care, everyone. Have a good night.
Thanks. Bye.